Hello everyone, today I'd like to introduce our paper about research of CPA attack methods based on Uncloning Algorithm. Firstly, let me introduce our team and members. We are from Beijing Electronic Science and Technology Institute in China. We have been engaged in the research of chip security for a long time. There are 4 co-authors engaged in this paper. Xiaoyi is now an associate professor of Beijing Electronic Science and Technology Institute. His main research interest is information security. Liu and Tong Jianmin are now graduate students in Beijing Electronic Science and Technology Institute, major in electronics and communication engineering. Siman, corresponding author, received her bachelor degrees from Beijing Electronic Science and Technology Institute. There will be 4 main parts of our presentation. First, we'll give a brief introduction of CPA. Then, we'll talk about the Uncloning algorithm. And then, we'll show our experimental data and relating analysis. And last is the conclusion of our work. The power analysis attack is an effective method of attacking encryption devices for leakage of side-channel information. CPA is a common method. The traditional method of power analysis attack, which is only one byte key, is analyzed in one attack and repeats multiple operations to obtain the whole secret key. In this way, a successful attack needs more power curves. In this paper, a new attack method is proposed to select the optimal secret key group through the uncloning algorithm and attack all the bytes of the secret key simultaneously. It can greatly eliminate the influence of the channel noise and improve the efficiency of the attack. Power analysis attack is a method of attacking encryption devices for leakage of side-channel information such as time consumption, power consumption, or electromagnetic radiation during these devices' works. CPA is less affected by the noise, and attackers using CPA do not need to know the detail about the attacked device. It has become one of the main methods of power analysis attack for domestic and foreign scholars. At present, the research of energy analysis attack focuses on the relationship between the energy change of a byte in the chip and the hypothesis model. The new CPA attack method proposed in this paper is an innovative application of the uncloning algorithm. This approach takes full advantage of the leaking of the whole 8 X boxes, significantly reducing the number of power curves and increasing the success rate of attack. The new method can efficiently use the limited power curves to analyze and increase the possibility of obtaining the correct secret key. CPA establishes a Hemi model and analyzes the coefficient of correlation between power consumption sample and the Hamming weight of the processed data. The main idea is that when the attacker knows the plain text, he can change the plain text and collect the corresponding power curves. In the CPA attack, calculating the correlation coefficient is a very important part to be distinguished from the other side-channel attack methods. The highest correlation coefficient is corresponding to the correct key. Otherwise, the intermediate variable and power consumption have not the expected relationship of direct proportional due to the wrong key. Therefore, existing CPA methods cannot obtain the correlation coefficient between the high power consumption and the success key. In the case of large noise, the correlation coefficient between the correct key and the wrong key may be almost the same. Therefore, the correlation coefficient analysis methods still need to be improved. Italian scholar Dorigo found that the ants can release a chemical called pheromone in the path they passed through. The ants can walk along the path of higher concentration of pheromone, and every passing ant will leave pheromone on the road, which forms a positive feedback mechanism. After a period, the entire ant colony can reach the food source along the shortest path. Inspired by this behavior, Dorigo proposed an evolutionary algorithm called Uncloning Algorithm. In essence, the Uncloning algorithm is a new heuristic optimization method. Its flowchart is shown on the left. Uncloning algorithm can be applied to many optimization problems. Unt's working path represents the feasible solution of the problems to be optimized, and all the passes of the Unt cloning form the solution space. In the optimal path, the Unts released more pheromones, and in the inferior path, the Unts released less. With time, the concentration of pheromone accumulated on the optimal path and the number of Unts choosing this path is also increasing. In the end, the whole Unt cloning will concentrate on the optimal path. Energy analysis attack can also be considered as an optimization problem. The key with a higher correlation coefficient corresponds to a better path, and the one with a lower correlation coefficient corresponds to a poorer path. The final optimal solution is the correct key. In order to generate the guessed key by Unt cloning algorithm, first, a map must be established between the guessed key and the Unt path. As shown on the left, each bit of the guessed key can be regarded as a node of the path, and each complete Unt path corresponds to a guessed key. The Unt cloning algorithm was originally used to find the shortest path between 2 points, and the evaluation indicator of the pros and cons of the path is the length of it. If the Unt cloning algorithm is used in the CPA attack, it is necessary to replace the indicator by the probability of the guessed key being the real key. This can be judged by the correlation coefficient. The higher it is, the better the path is, and the lower it is, the worse the path is. In each round of iteration of the Unt cloning algorithm, an optimal path will be found. That is, the guessed key with the largest correlation coefficient. It can generate the Unt path of the next round iteration according to the best path in this round. Using the correlation coefficient of this optimal path and the other passes of this round, the relative error value t can be found respectively according to the following formula. Therein, a is the absolute error and b is the true value. The relative error value t can determine the search range of the Unt cloning in the next round of iteration. If t is less than 20%, then the iteration path of the next round will be generated in the vicinity of this path with a certain probability. If t is greater than or equal to 20%, then the iteration path of next round will be generated in the global scope with a certain probability. The probability of choosing which road at each branch depends on the concentration of pheromones on that road. In other words, the concentration of pheromone will affect each value of the guess key value. Finally, the termination condition of the Unt cloning algorithm needs to be set. Since the solution space of the real key is too large, we cannot and do not need to successfully verify all the solutions in the entire solution space. Therefore, we regard the number of iterations as the termination condition of the algorithm. When the preset iteration round is completed, the shortest path is output, and its corresponding guess key is the correct key calculated by the algorithm. The Unt cloning algorithm may tend to converge and achieve the correct key before the preset iteration round is accomplished. If the preset iteration round is too small or too large, the Unt cloning algorithm may or may not converge, and the correct key achieved is not the true key. Based on Unt cloning algorithm, now is our experimental data and analysis. To obtain reliable experimental data, a powerful platform is established, which consists of 3 parts: encryption equipment, data acquisition, and data analysis. The specific sets are shown as below. In this experiment, the attack target is the output bytes of S-box in the first round of AES 128. First of all, we keep the related parameters of the Unt cloning algorithm unchanged and use different numbers of power curves for CPA attacks. The success rate of attack with the original method and the new method is separately recorded, as shown on the left. CPA attacks using the original method have a success rate of 0 when the number of power curves is less than 3,000. With the increase of the number of power curves, the success rate of CPA increases. When the number of power curves reach 6,000, the attack success rate of the original method reaches 100%. When the number of power curves is less than 6,000, the success rates with new methods are higher under the same amount of power curves. Therefore, it can be inferred that the new method can achieve higher success rates with fewer power curves. It is important to reduce the number of traces needed to successfully attack. The new method can efficiently use the limited power curves and analyze to increase the probability of obtaining the correct key. As the data utilization being improved, the number of power curves can be substantially reduced. A considerable amount of analysis and processing time and data storage space will be saved. When using the original method, it takes about 1 minute to verify each byte of a guess key, and completing the computation of all the 16 bytes may cost 16 minutes to 4,096 minutes in theory. While using the new method of CPA attack, the same power curves of 4,000 can accomplish the attack within 4 hours. If you ignore the data loading time, it needs less than 2 hours. For computation itself, our method saves 97% of the computation time than original method. As the experimental results show, the new method is far superior to the original method in attack success rate, the number of power consumption curves, and operation time, which fully verifies the effectiveness of the new method. In addition, we compared and studied the influence of different numbers of ounce and ounce movement times on the success rate of the attack and the average computation time. We keep the other parameters unchanged and record the success rate of the CPA attack and the average computation time with different numbers of ounce. There is a positive correlation between the number of ounce and the success rate of CPA attacks. Simultaneously, there is a positive correlation between the number of ounce and the average computation time. Since the increase in the number of ounce does not increase the cost of time much, it is a good choice to appropriately increase the number of ounce, which can enhance the success rate of attack. Then, we keep the other parameters unchanged and record the success rate of the CPA attack and the average computation time with different numbers of ounce movements. In this experiment, we can conclude that the optimal number of ounce movements of the Uncloning algorithm is 50. To ensure that the experiment results are not affected by the number of ounce, it is set to 200, leading to a longer average computation time. It is more appropriate to repeat the experiments until the ounce number is adjusted to an optimal value. Finally, I'll give a brief conclusion of our paper. In this paper, a new CPA attack method based on Uncloning algorithm is proposed. Based on the traditional CPA attack, this method combines the advantages of the Uncloning algorithm, including distributed computation, information, positive feedback, and heuristic searchability. It can fast search the optimal solution in the whole situation to improve the efficiency of the CPA attack. Thus, it significantly reduces the number of power curves needed for the attack and increases the success rate of the attack with limited power curves. To verify this, we compared the attack results of the new method and the original method by the attack experiment to the AES algorithm. The experiment results fully validate the validity of the new method. During the experiment, we found that some parameters of the Uncloning algorithm, such as the number of aunts and the number of aunt movements, will have an impact on the attack efficiently. We briefly discussed this and gave some suggestions on choosing the best parameters. The new CPA attack method proposed in this paper is universal, so it has a certain value for power analysis technology. That is all of our introduction of the paper Research of CPA Attack Methods based on Uncloning Algorithm. Thanks for your listening. Goodbye.